Thanks, Brad. As Brad said, we're going to go over some roadway rehabilitation and maintenance options and how to utilize the pavement management software. And then Joe's going to go into some detail on the design engineering and the pavement maintenance related items. So first thing we're going to talk about is how to utilize the pavement management software. So you get a lot of data through the software. We're going to go through some stuff about how to implement that data and how to interpret it to come up with what your rehabilitation options might be. Go through how we determine what rehabilitation options to do, whether you're going to do pavement resurfacing versus pavement reconstruction. And then Joe will talk about the design engineering that will go into that based on which route you choose, and then we'll talk about the preventative maintenance as well. So first, just utilizing the pavement management software. So any roadway inventory data that you can have is going to go a long way to trying to help you interpret the data. So when was the original road constructed? When was the last year it was rehabilitated? Roadway functional class, is it a collector versus residential versus arterial? So why those are important is obviously original construction year, it's nice to know when the road was originally constructed and what has been done to the road throughout its life cycle. Is this the fourth or fifth time you're resurfacing it? Is it the first time? Has it been reconstructed in the past? The last rehabilitation year is important so that you can understand when it was last resurfaced or last rehabilitated, and then compare that to the PCI that you have to determine, if what you've been doing in the past is getting the lifespan that you would have expected. And then the roadway functional class, one thing you can do with these softwares is you can analyze your residential streets or just even one single subdivision by itself if you wanted to, or you could analyze only your collectors or your arterials, and you can have different decision trees for your collectors versus arterials versus residential. Obviously, typically you probably want to maintain a higher level of service and not let your PCI drop as far on your on your collector and arterial streets versus your residential. Other important information would be obviously roadway type. That's going to go to determine what sort of rehabilitation options you might have. Analyze your drainage conditions. Is it a rural pavement section versus a curb and gutter? That will change your cost per square yard that you would typically use in the software to determine your cost for each roadway. Any existing pavement data, traffic counts, existing pavement information, existing plans will kind of tell you what the existing pavement structure is. Is it adequate? Was it based on a older standard and you want to update it to a new standard? So all that kind of goes into determining what rehabilitation method you want to use. Once you kind of gather all that inventory data, you can use the program to analyze different things. So what the program can do will tell you how much of a certain distress you have in that specific area. And what is powerful about that is you can analyze what those types of distresses are and the severity, and that will give you a little bit of an idea of what potentially is going on with the pavement. And then you want to analyze your current PCI rank, look at the curve, and it'll age out your future PCI rank to see what it's going to be if you don't do anything to the street in 5 years or 10 years. You can analyze the subsurface conditions and base conditions, and then ultimately that software will provide you with a recommendation of what to do to each street. And then you can use your engineering judgment to determine if the software, what it recommended is appropriate, or if you want to try and do something different based on the information that you have. As talked about, you want to review the existing pavement conditions and review the stresses. So the pavement softwares would typically take pictures of the roadways that they're surveying every 10 to 15 feet. So you can almost drive through the road, just flipping through the photos and look at the condition of the road. And that picture there is an example of a picture that was taken in the community that will show you what's going on that road. And what's important is to determine those types of distresses and what they mean. So, transverse cracking versus alligator cracking, that's a difference between whether or not you have an issue with your base potentially, or if it's just an issue in the surface. Same thing with the rutting versus the block cracking, and I will go into examples of what those look like. And then the severity is important because obviously a high severity is going to be a lot more important to fix than a low versus medium severity. So here's some examples of some pavement distresses. Obviously, potholes, I think we're all familiar with those with our amazing winters that we have. Alligator cracking there on the right, that's usually an indicator that you possibly have some base failure and moisture in the base that's causing that cracking to happen, as well as the rutting there in the bottom left. So that would be something that would be a red flag typically that you're going to have to do at the minimum, probably some sort of undercut or base patching there. You won't be able to just resurface over the top of that. Versus some of your more just surface cracking, transverse and block cracking is typically because of your freeze-thaw cycles where you just get cracking on the top layers and weathering just due to traffic and the winters that we have. So taking all of that information together, we kind of analyze all those things to determine what we want to do to each street. So taking the first step would be just coordinating, reviewing the recommendation from the pavement management software. Does it make sense? Is it something that you want to do? For instance, some communities, they don't want to reconstruct the cul-de-sacs because they get low traffic. So you might say, well, I don't want to, even though that's what the software recommended, we're going to just do a resurfacing there. You want to do your data collection, get your existing data, try and gather any existing plans or any existing information on the roadway, get your geotechnical engineering done, pavement cores, for sure. So what's shown there obviously is some pavement cores, and what's important about that is that's going to tell you what your existing pavement section is. How thick is your existing asphalt? How thick is your sub-base stone below? That will tell you a lot of times whether or not the existing pavement section's adequate based on the traffic and the roadway functional class that you have. Another important thing about the cores when we get into some of the other things we're going to discuss is about the existing pavement interlayers such as Petromat or other fabrics, because some of the alternate strategies can't be done with those fabrics being done. And then obviously if you think you might have pavement reconstruction, you want to get soil borings to understand what the subgrade below the roadway is. You want to do your CCDD or clean construction demolition debris to make sure that you don't have any contaminated soil or any soil that needs to go anywhere. And then get your full report to be able to analyze what the existing subgrade and pavement conditions are. Then the fourth would be to determine your roadway rehabilitation options. So you want to make sure you're determining the correct and most efficient rehabilitation technique. You don't want to be over-designing, but don't want to under-design either based on all the information that we've talked about. And then utilize the pavement management software. So what's shown here is just from one program at the top is the paver program. So you can see on that section of pavement, there was some alligator cracking of medium severity and what the quantity was. It'll tell you you had some longitudinal and transverse cracking, and that will go a long way, as discussed, to determine what you want to do. And then the bottom picture there is an excerpt from the PavePro software, which will tell you the street that's highlighted there, Alice Avenue. There is a cracking score of 48 out of 100, so you've got a lot of cracking, which has an overall surface score of 58, but your deflection score, which would be your base score, is 100. So that would tell you that your base is good there, but your surface needs to be resurfaced. So that would be just a candidate for a resurfacing project. So at this point, you're kind of faced with, do you want to do the pavement resurfacing or you want to do pavement reconstruction? So the first thing that we'll talk about is just pavement resurfacing options, things that go into it, and then a alternate cost-effective when appropriate solution called hot-in-place recycling. And then we'll also talk about pavement reconstruction as well. So pavement resurfacing, I'm sure everyone in the room is familiar with this, just your traditional resurfacing, standard mill and overlay with varying thicknesses. Obviously, the more you mill off and put back, the more expensive it is. Provides a new wearing surface. The costs can range anywhere from generally $18 to $36 a square yard, depending on various factors such as what your curb and gutter condition is, what the ADA requirements are, whether or not you want to include sidewalk repairs in with your program, what patching percentage you determine, and then generally the average cost is about $27 a square yard on most of our projects we've been working on. So the patching percentage, that's where, as Tim talked about, with that pavement management data, we'll be able to tell you if you think you have base problems or you might have base issues, you can do that heavy patching to try and fix that base, which is traditionally going to be cheaper to do it that way than just remove and replace all of the existing subgrade. So concrete repairs, each community is different and has their own standards, but at a minimum, typically you want to fix anything that's not draining, such as the picture there in the middle. That picture at the top, you'd probably want to fix that curb as well, because you're going to get a lot of moisture going through all those existing cracks, going down into your base. And then everyone knows that you got to upgrade the ADA sidewalk ramps to the most up-to-date detail. Whether you want to add any trip hazards or any other sidewalk would be community dependent, but typically it's more cost effective to do it while you have a contractor there than do it in a separate program, but that would be community specific. Patching repairs, I would say standard is usually throw on 3 to 5% just in case you run into some issues after you mill the surface. But if you think based on the pavement management software recommendations and information that you might have additional base repair, then you might want to throw a heavier amount of patching at your 10 to 15%. The thickness will vary whether you want to get all the way down to the base, if you want to go into the base and do base removal as part of your patching, and then, or if you want to do undercuts and then patch it back, those are all options as well. Sometimes it is more cost effective to just mill all the way down to the existing stone and proof roll, do any undercuts, and resurface the road. So this would be one where maybe it was an existing road that was built that was only 2 or 3 inches of asphalt on 12 or 13 inches of stone, and you want to get 4 or 5 inches. Well, maybe you mill off the whole section, mill off some of the stone. You would proof roll, do any base repairs that's needed, and then go over the top based on whatever thickness you want to put back. A lot of times that's a lot more cost effective than doing an entire reconstruction and ripping out all of the existing stone and pavement section. So those are all kind of different resurfacing considerations that would go into your traditional resurfacing options. An alternative would be to do hot-in-place recycling. So what the hot-in-place recycling is it's a train of equipment that goes through and heats the asphalt back up to 300-400 degrees into a working condition. It takes a scarifying unit that goes through and scarifies off about 1.25 inches to 1.5 inches deep. It'll go back through a screed, and then it'll get paved back down, and then you would put a new layer on top of that. So for curb and gutter areas, obviously you need to mill off whatever thickness of your wearing surface you want to put on. So if you want to put 2 inches of surface, you'd have to mill 2 inches of surface first, then come in and do the hot-in-place recycling. There is a high mobilization cost, so you would want to do a fairly large section of roadway to do this. You wouldn't want to just do 1 or 2 blocks. It can be, there's a long equipment train. It's usually about 40 feet with the unit that heats the asphalt back up, the scarifying unit, and then there's a unit that adds in an asphalt rejuvenator back in and pays it back down. So with that, it's a little bit difficult to get around really sharp curves, and obviously you can't do it in cul-de-sacs, has a hard time getting around some radiuses, and then it cannot be used, this is where, as mentioned before, cannot be used on areas that have pavement fabric because the scarifying unit won't be able to tear up the fabric. So what's shown here, as discussed, is the scarifying unit. So there's little like tines that go through and scarify the asphalt up to about 1.5 inches, and then that's where they introduce the asphalt rejuvenator, and then you just use a standard paving screed to put the recycled material back down to your standard compaction methods, and then you would overlay with a new asphalt surface. And typically this can save you, because you're not replacing that 1.5 inches of existing asphalt, you're just reusing what's there, can save you a little bit. So the typical costs with your overlay and your concrete improvements can be anywhere from $14 to $20 a square yard. So based on the information that was discussed earlier, if we determine that the pavement reconstruction is the correct route to go down, then you know, you'll have to completely grind off the existing pavement, and then you'll typically got to remove and replace the existing base course, proof roll the subgrade, and maybe make repairs to the subgrade. Obviously, this is typically a very timely project. It takes a long time for the contractor to remove all the material, get it all graded out, has a great impact and effect on the residents. It's extremely expensive because you have to haul off all the material to either a CCDD facility, or if you're unlucky and have contaminated soil, to a non-special waste facility. And then obviously it typically involves road closures, possibly detours, and typically doesn't make people very happy. But sometimes that's what's needed and recommended in order to get the lifespan you want out of the roadway. Sometimes you obviously make some adjustments to the existing profile to be able to get the road to drain properly. Sometimes it involves utility improvements such as water main or storm sewer replacement, or sanitary sewer improvements. And then your typical costs can be range anywhere from $75 to $140 a square yard just for the road portion of it. That would not include any utility improvements in that as well. So what we're going to talk about is an alternative to that when it makes sense, which would be to do full depth reclamation with either cement or lime stabilization. So in this option, you are, again, completely removing down to whatever depth of asphalt you want. So if you want 6 inches of new asphalt, you remove 6 inches of existing pavement, could be an existing base. And then you would utilize the existing base material and implement in a additive to strengthen your base into a new base, basically, and then you would pave over the top of this. It does require you to do a detailed mix design to determine how much of the additive that you need to add. And then, so yeah, the pulverization mixes the material and creates a new homogeneous base material with an additive, as discussed, such as cement, lime, or asphalt. So what's shown in the top left there, that's the reclamating machine. It's the machine that comes in and churns up the road. You can typically do anywhere from, I want to say, 8 to 16 inches deep of reclamation, and then it would put down the new base, which is shown there in the bottom left, and what's shown in the bottom right there is what the existing roadway looked like. This particular project that we utilized it in was an area where the community had existing pozzolanic base and had a lot of issues with freeze-thaw, and we were able to use this full depth reclamation to remediate that and put it back down, and it saved, obviously it was a little bit more cost effective, but they were also able to get it done a lot quicker, so they were able to do the full depth reclamation that we did for this project in 2 days, as opposed to probably 2 or 3 weeks worth of doing the traditional reconstruct. Couple things to note would just be it's economical when applicable, but there is high mobilization costs. So again, you want to make sure that you're doing a large section. In this particular project, we did I think like 1.5 miles of improvements. You don't want to just be doing a couple blocks. Good candidates are roads that exhibit base failure but have good drainage. So it's important to make sure that you have well-draining base, and if you don't, then you might have to use lime instead of cement to stabilize that, or you could potentially have to add in under drains to make sure that you're getting your base to drain properly. If you don't get your base to drain, you can have freeze thaw issues with heaving in the future. And then it can, as discussed, will greatly decrease the number of times residents will be affected versus the traditional reconstruction. So it's able to be done under traffic, and once they're done doing the reclamation and the cement, the residents are able to drive on it the same day while the cement's curing. It must be overlaid with a binder and surface course, and then it is much more cheaper and environmentally friendly than conventional reconstruction. So what's shown here in the pictures would be after the reclamating machine comes through and reclamates up all the existing material, there's a cement truck. In this project we use cement truck that comes in and puts the cement back down. And then there's a water truck that will hook up to the reclamator, introduce the water, and mix the material back up. And then what's in that bottom right would just be your traditional road grader grading out the new base. They'll roll and compact it, and then let it cure. One thing that you want to do with the full depth reclamation with cement is to check for whether or not you need to do micro cracking. So if the full depth reclamation gets too strong, basically, you come in and basically take a roller to micro crack the top, and that will prevent you from having your base kind of act as concrete, and will give it more flexibility so you don't have as much of the heaving issues. It typically costs from $40 to $65 a square yard, depending on how much of a overlay that you add. And how much concrete improvements that you perform. And then the last kind of reconstruction that we did in a community in the village Montgomery, they had existing alleys, downtown alleys that the village is required to maintain, that they that people have their driveways off of, so they just get residential traffic. And they had they did not have a lot of good areas to be able to drain the water. There's a couple dips in the middle of them, and so the village came up and we came up with the solution to put in porous hot mix asphalt. So what happens is the water will go through the asphalt into the base below, and then we did a permittivity test of the existing soil to determine that it was able to permeate back through the soil. Because they had a lot of sand and gravel in that area, but we did still install under drains just as a extra measure to make sure that that base does get drained. And you can see the difference in the pictures there. So the one on the bottom left was probably the alley that was in the worst condition and had a big belly in the middle of it with no outlet for the water. And then that picture on the right is, after a rainstorm, what it looked like. So it's been a good success to help those alleys drain and also get them a new wearing surface. Obviously, you want to make sure, because of that, the structure of the existing asphalt is obviously very porous. It's not good candidates for areas with high turning movements and high truck traffic. So in this case, it's just very few turning movements required, and it was just in a residential area with residential cars. Now Joe is going to talk about some of the design engineering. I guess, does anyone have any questions before I pass it off to Joe?
I was wondering for the base ratings, like what type of testing that you suggest for that with the pavement management program?
Okay, so the question was, what type of testing do we recommend for the base conditions? So typically what they'll do is what's called a falling deflectometer test. Well, they'll apply a load, and then typically it's done once every block. And what they'll do is they'll have 4 or 5 sensors that will pick up how that load is deflecting the pavement, but also the base and the subgrade below. So that would be that would be what was typically recommended when you do the base testing.
Is pavement age factor in the hottest place or something?
The question was, is pavement age a factor in the hot in place recycling? I would say pavement age and condition would be important. So obviously the older the pavement, generally the more rejuvenator you're going to have to add in because you've oxidized and lost a lot more asphalt than if it was newer. The other thing is typically the way that I would think about it is with the way that it looks like below is kind of what it's going to look like when you put it back in. You're not generally adding any extra material or anything, so you want to make sure that it's got, it doesn't have base failure or any of those issues if you were going to use that option.
For the reclamation, is the base design or existing condition, how much does that impact the application? Because from the photos, it looks like you had a compacted soil sort of base with maybe a couple inches of stone or something.
I guess could you clarify a little bit more?
So
I can go back to the pictures.
yeah, I was just trying to determine, right, so it doesn't look like there's a lot of undercuts or additional excavation in these photos for this reclamation process. So I'm trying to determine, is that soil that's existing and being compacted? Is that soil that's been brought in or what?
That's existing aggregate base course. In this case, was existing aggregate base course and pozzolanic base that got ground up and then put back down, and the cement and water got all mixed together to make a new material.
I see.
So that's what that picture that's getting graded is showing. Is that's what it looks like.
That's the
new base that's being used.
I see. Okay. That makes sense.
All right, I will pass it off to Joe.
Thanks, Chris. Design engineering considerations. So I'm going to speak a little bit about how we develop the design for road and street programs, resurfacing programs. There's some items here that I want to speak about. Field inspection. So one of the first tasks that we do, our designer or maybe two get their vests on and head out to the field. We go and check for, conditions of the pavement, areas where there might be potential patching that's needed. We also look for areas of curb and gutter removal and replacement, and also sidewalk removal and replacement. On sidewalks, we're looking for trip hazards. A lot of municipalities have their own criteria for how much they're willing to replace, what condition, how many cracks in the curb there are. Then there's also ADA compliance. I'll be speaking a little bit more about that. Utility coordination, always important in any project, no matter the size. Making sure that the utilities know that there's a project happening, making sure that there's no conflicts. Some of the cable companies do put their cables pretty shallow, so it does happen that we run into issues on removal and ADA improvements. And then pavement permit coordination. A lot of sometimes your projects are going to extend into IDOT and county right away. In those cases, you're going to be required to get a permit. There's also times where you have to replace detector loops. IDOT uses detector loops for all their traffic signals. So anytime you're going to be impacting those detector loops, you're going to have to get a permit through IDOT. Other items are CCDD, IEPA coordination for the removal of any soils. And then we'll go about the roadway design. Is it full depth reclamation? Is it mill and resurface? Determining typical sections. Sometimes on some projects our clients want to change the radius return of an intersection. Those items will all be taken care of in the design, roadway design. And then there's other considerations. Some of those are drainage. We go out there, we try to go out on the field after it rains to see how the roadway is draining. Is there a need for additional inlets? Sometimes we even have had lengths of storm sewer to make the pavement drainage better. And then when we're out in the field, we also check the structures. Are there any that need to be reconstructed? What's the condition of some of the structures along the roadways that we're resurfacing? So project plans. Not all projects are required to have plans. Maintenance section, MFT projects are not required to have plans. But if they're required, we would provide plans. Typically, there's always specifications. If there's not plans required, there's always specifications. And then the cost estimates. Well, one of the most important parts of these projects is the cost estimate, making sure that you have enough material in there so that it reduces the amount of change orders in the field or extras that come about. We also like to put in a little bit of fluff, especially on asphalt for, loss of material. Also, changes, sometimes add a, couple of sidewalk squares, make sure, because once, when you're doing the ADA stuff, sometimes you end up having to replace more squares than you thought you would. And then QCQA, the cornerstone of good quality work, is a necessity on every project. So we would do hopefully someone that hasn't been, a fresh set of eyes is the best person to QA a project. They can catch things that the normal designer would, had been looking at it for months, won't catch. Oops. My fault there. There we go. ADA compliance. So up there's an example of a sheet that our field guys take out to the field. They use their smart level. They go and start measuring the slope of the squares, and we fill out these corner sheets, come up with the best design for replacing those ADA ramps. Sometimes full topographic survey is necessary because the area is, steep or whatnot, and sometimes you'll have to put curbs in order to make the ADA work, and sometimes you'll have to replace several squares back from the corners. So we do all that in design. The project plans and specifications, Rebuild Illinois funds, bond funds, which I'm sure you're all familiar with. Any projects that are utilizing those funds need to have plans and specifications. Also, any projects that are considered by IDOT to be a construction section and not in a maintenance section would require plans. But if you're just using MFT funds on a maintenance section, you would just need a bid package and specs. Typically in those specs, we would put exhibits showing, typical section exhibits showing what the work is going to be done. We'll have exhibits showing where the ADA ramps are that are to be replaced, but they wouldn't be a detailed set of plans. So resurfacing considerations. If you're going to be resurfacing, obviously the overlay thickness, Chris had brought it up. Are you milling off 3, putting back 3? Are you milling down to the stone? What asphalt mix are you going to be using? Do you have your own municipal mix? Some do. What type of aggregate, and bitumen are you going to use? Do you have a unique mix design that you want to use on specific streets? But if you are going to be using MFT funding, you will be required to use the IDOT mixes, which is shown in the table there. The mix table, it's based on ADT, and you would be required to use those mixes. Longitudinal joint sealant, it's something that's newer, but most projects it's actually an IDOT standard now. It increases the density between paving passes. So wherever your paving joint is going to be, you put that down on the binder before you pave surface. And it, it helps to prevent water from seeping down, because that first crack down the middle is usually the first crack you see. And that will help, it increases the density of the pavement there and prevents the water from getting down deeper into the binder and then eventually into your base. So a lot of projects are using this these days. We use it quite a bit. IDOT's using it now. It's definitely a good method to keep those joints dry. Then we got the reflective crack treatment. Between the surface and the binder, you can put a polyamide type binder that will, or a fabric type material in between that layer that acts sort of similar to the longitudinal joint sealant. It prevents, it helps keep the cracks from protruding below into the binder course of the pavement. Preventive maintenance. I'm going to talk a little bit about some preventive maintenance items. Here I got some figures here that show kind of what the pavement looks like in cross-section view for each type. This one would be a very good pavement from 4 to 7 years. As you can see, the center line crack is barely visible at the surface. And then here is a good pavement from 8 to 10 years. The center line crack is now well into the pavement structure. You're starting to see other cracks develop on the outsides and in the middle. And then here is a poor 15 plus years pavement. Your center line crack has made it all the way down to the base, which is not good because water's reaching there now. And you have a lot of other cracking that's happening across the pavement section. So here's some items that both Tim and Chris talked about, ways to intercept that curve and extend the life of the pavement. Asphalt rejuvenator, it's an application of a thin layer of emulsion that's placed down. After they place that layer of emulsion, they typically spread sand across the road, and the sand is for traction purposes mostly. So because it gets pretty slippery when you put the emulsion on. This is typically applied like 1 to 2 years after resurfacing, so it's something high up when your PCI is still pretty high. It's a way to extend the life and change that curve, as Tim had talked about. It takes about 15 to 45 minutes, and when they spread it, you'll see it on the surface, and when it's gone, you'll actually see that it's gone, and then they spread the sand on there. And this typically extends the life of the pavement from 3 to 5 years, and it typically costs $1 to $1.20 a square yard. Crack sealing, everybody's I think familiar with this one. It's utilized pretty much everywhere. It prevents water from penetrating the base. You're going to want to seal the cracks as you see them. A lot of municipalities will have a crack sealing program to go out and crack seal as soon as, after the winter, find cracks, seal them right away. It can't hurt. You're going to prevent that water from getting to the base, and that's what you want. You want to try to stop that as soon as possible. And, typically, you do them as you see them, and the previous graphs is like year 4 is when you start to see the cracking, and that's, 4 to 6 is when you're going to start seeing more cracking, so you're going to want to get out there and seal them. And that's typically 45 to 60 cents per foot. Microsurfacing, it's another preventative maintenance option. It's typically done around the 8 to 12 year mark. You're going to want to crack seal and do any patching prior to doing this microsurfacing. It's an application of a thin layer of emulsion, and the road, it's ideal for roadways that have higher volumes of traffic without difficult application areas. So areas where the road is real curvy, there is a little bit of equipment train here, so it does have difficulty getting to those tight corners, even though you can still do it by hand. It's important to know that if you do it by hand, the surface, it doesn't come out the same as if it's placed mechanically, so there will be a little difference in color and whatnot. It's also important to do a little public outreach on this because of this, mostly because of the sand, just so people realize why the sand is there. It will be vacuumed up the day after, but people will drive over it, so it's important to have a little public outreach. It typically costs between $4.50 and $7 per square yard. So here's a kind of a, back to Tim's curve, here's a typical deterioration curve, showing it PCI versus age. And then here's what the new deterioration curve could be if you do preventative maintenance. You could see the curve at the top is flatter. It keeps the pavement PCI higher, and you extend the life of it. So in conclusion, utilizing the pavement management software, it's the start of your CIP program, determining the proper rehabilitation methods. Are you going to resurface? Are you going to microsurface? Are you just going to mill off 2 and put back 2? Your design is important. It can give you good unit prices, the timing of when you bid the project, making sure all your items are there. It'll prevent overages in the field. You'll be well aware. You'll be able to budget well with a good design. And then obviously the pavement maintenance can optimize the life of your pavement, and it could intercept that deterioration curve and extend the life of your pavement. Is there any questions?
What are your thoughts on routing as part of the crack fill project? Just recommend it, or just crack fill without going through the routing, fracking things?
So the question was how I felt about routing. I personally think that, and I'll let Chris chime in too, is that it would depend on the width of the cracks. If they're wider, you really don't need to route it, in our opinion. But if you are gonna if they're gonna be narrow cracks, I think then routing would make sense because you're not gonna get it down in there enough. That's. What do you think about that, Chris?
Yeah, I would agree. Generally, I would recommend doing the routing, because what I found is if you don't do the routing on the smaller cracks, is that the crack seal will just come up the next year after the snow plows come in. So yeah, generally, we would recommend doing routing and then doing the crack filling. The larger cracks, like Joe said, they're big enough that you probably don't have to do it, but the routing's so cheap, it's usually not that big of a deal.
What's your opinion on the LJS milling? Like after you place it, then the next time when you come through and mill, does it come from the machines or does it get ground up well?
I haven't heard any issues with that. I think it's not like a fabric, so it grinds up well, is from what I've heard. And I'm pretty sure IDOT would.
Yeah, so when you put it down, it goes down like the way that it's shown, but when you put it back, you put the asphalt on top, it actually heats it up and turns it back into a liquid. So you don't actually have like a fabric or anything that's there. So it would just get ground like a normal road.
Okay,
What about fiber versus rubber crack filling?
Fiber versus rubber.
Typically, they would recommend doing the fiber modified crack sealing when you do the microsurfacing, but you can do The rubber, I think, it works fine with the roadway, but the fiber probably is better, but it's also more expensive.
Are you aware of any recent studies of data showing how effective the rejuvenators are? We've used them in the past, but have a hard time justifying them to the higher ups as the results that are not obvious.
I personally have not seen any studies, and I did look a little bit before today. I have not seen any studies on that yet. We do have a couple municipalities we use that do it. I know we use it on bike paths too. You know, right after the year after a bike path is paved, a shared use path. But I have not seen any studies on that.
Was that your Rehab project, is that something that you use that MDL or support yet, or is that through the material?
No. I believe microsurfacing too is not, or is that, it is, oh, they just recently approved that, right?
You use the LJS on surface roads, or is that for divine or clean? Should that be applied over
Like
Yes.
on the built surface?
I would think so.
I've not done it that way. I've usually just done it between like the binder and the surface, but I'm sure you probably could. But I don't have experience with that.
What I've been trying to do with the LJS is see if anybody's been using it against the curb line so that it can, when the capillary actually can draw it up and kind of seal that instead of rubberized crackle and routing along the curb line. Nobody seems to know anything, but you have to done it.
Well, a lot of our municipalities actually route along the curb and crack fill.
So
Yeah.
I was curious if you can kind of incorporate that into the paving process where you don't have to come back. People are calling angry. You just did this road a year ago. Why are you routing things? Why are you doing things? So if you can somehow incorporate that into paving, where then that you could maybe place the LJS along the curb line and draw it up that way.
Yeah, no, that's a good idea. I have had projects where we've used it because we've had more than just the joint at the crown. We've used it at other joints across the section, but I haven't yet to do that. That's an interesting idea, though.
Have you come up with any alternatives for curb repairs other than remove and replace? We spend a lot of money doing curb repairs. There's something for minor breaks that might be more cost effective than full removal. I've heard of using shotcrete, but I've also been told that seed blade is expensive to replace.
Yeah, most of our municipalities that we work for have been removing and replacing. I mean, we grind the curbs sometimes, right?
I would say it depends. I mean, if it's a drainage issue, obviously it's got to be replaced. But I think one way, you know, whatever, depending on your community standard, is instead of removing and replacing like some of the cracked curb, maybe you just epoxy, you know, you saw cut and seal that crack as opposed to replacing the whole section. But in terms of like spalling and stuff, you could do like an Ardex or an epoxy material. But I would have some concern about just the longevity of that, especially with the snowplows and everything going by.
We've used the LJS in industrial areas or commercial areas, so less driveways, more straight throughs with a concrete base, but not in the residential areas. Our concern is the driveways, the backing in and turning out. Has anybody had any issues in a residential area with it picking up, or?
None at all. In like 15 minutes it breaks and it's fine.
Okay, thanks.
So the question is there any issues in residential areas? We haven't run into any issues with it coming out.
The backing in and out, you know, versus just a straight linear.
Yeah, no, I haven't run into any issues on that.